Assalamualaikum warahmatullahi taala wabarakatuh. How are you? Okay.
Waalaikumsalam.
Okay. Now, before we'll have the quiz today, but we'll have it to the end of the class. So for now, for the half an hour, we'll have the quiz about 40 minutes. Now we are going to do the first derivative test. Now, if you recall, I stopped at that point where we were talking about the relationship between the, what do you call it, the derivative and the behavior of the function. So that is where we stop. We can see here when the derivative is negative, for an interval, the function is decreasing. And if the derivative is positive over that interval, over one interval, then we see that the function is increasing. Okay, next. Now, when you have this kind of function, normally you will have something like this. You go to the book. The book has a good picture. Go to 10.1. Okay, 10.1. You go to the graph. Did I ask you to see the picture? Okay, you look at the picture on figure. Figure 10.1b. You see the curve over there. You see the curve. The curve is going down, and then it goes up. All right. So I want you to see the graph. Okay. So I will draw you another one. Okay, I'll draw you another one. The book doesn't have it. So another one, you will have something like this. Okay, I have y equal to f of x. So I will talk about this one first. Okay, this one is in the book. Called this C lah, because 1a is a different picture. Now, if you look at this curve, we can see that if we go from the left, all right, you go from the left, the function is what? The function is increasing since the slope is positive. Okay, so here the slope is positive, you know the function is increasing. And on the right side here, the derivatives or the slopes are negative. And that means the function is decreasing. Okay? But there is a point here. We call it a turning point or critical point. Critical point or turning point where the y prime is equal to 0. When you see here, the derivative or the slope, they change sign, all right, from positive to negative. So they will pass through y prime equal to 0, all right? And that point is called the critical point. And that point is very important. So that point, you call it critical point. Suppose it happened at x star, y star. Okay. So that's critical point. Critical point, essentially, where the y prime is equal to 0, suppose that happened at x star, y star, that will divide or break the function y equal to f of x into interval. So that will be the breaking point into interval. So if you can see here, that is x star. Then what? Then we have two intervals. One to the left here, the other to the right. The interval, will be defined by whether the y prime is negative or y prime positive. Okay, so if you look at the left hand side, the interval on the left, the y prime is positive. The interval on the right, what about y prime? Y prime negative. So there are two intervals here. We can denote that this interval negative infinity to x star, and the other interval is from x star to infinity. Okay, and of course, for each interval, you will see the y prime, how the y prime behave. Either y prime is positive or y prime negative, and from there we can conclude about the behavior of y. All right. Okay. Any question? Okay, now you refer to the diagram in the book 10.1b. You see the graph over there will be the opposite of what I have here. All right. Now I want you to look at the graph. Okay, what can you say about that graph? The line 10.1b. You look at the interval for which the y prime is negative, y prime positive, and where that y prime change sign, okay, that is the critical point. So we go from the left, right? We move from the left. What can you say about the y prime from on the left? As the curve goes down. What about y prime? What can you say about y prime? Look at you look at that thing. You look at the diagram. The diagram on 11.1b. Okay, on the left, what can you say about the y prime? Look at the graph. Look at the graph. The y prime is negative. Is that right? You sketch the line, or you use your book. Just draw the slope like this, right? So from on the left, the slopes are negative, or the derivatives are negative. Now, what happened as you move to the right? When the line is going up, what happened there? What about the y prime?
Positive.
Positive. Okay, good. So if you can see there, it's just the opposite what we had in the I just draw. Over there, you will see something like this. The line is going down like that. Okay. On the left side, you can see clearly. Okay, you just draw some. Okay, these are negative. Y prime negative. And over here, the other side, you see y prime is positive. So when y prime negative, what about the function? What about the curve? Going up or going down? The curve is going down, right?
Going down.
When y prime positive,
Down.
the function is going up. And there is a critical point here. That critical point is where the y prime is equal to 0. And we call it, again, x star, y star. All right. So that is critical point. Critical point y prime equal to 0 happen at x star y star. All right. So here you see on the left side y prime negative. That means the function is decreasing. On the right side, y prime positive function is increasing. And of course, it will pass through that critical point. Okay, that critical point where the y prime is 0. So that critical point, we call it x star y star. And based on, again here on the critical point, we can see there are two intervals, separate intervals. Based on what? Or for where, for which the y prime is negative or the y prime is positive. So here I got one interval, negative infinity to x star. And over the other side, I got interval x star to infinity. Okay, so we can see clearly over this interval, y prime is negative, the other interval, y prime positive. And if I go back to the diagram that I just drawn earlier, it's like that. Now, for this one, you have the function going up, y prime positive, and then function going down, y prime negative. So the turning point here, we have what? We have a maximum point. They call it relative maximum. So you have a relative maximum at what? At x star, y star. All right. Now, the other one, the other graph, which is based on the book. Here you have the function decreasing, y prime less than 0. Move up to the right, function increasing, y prime bigger than 0. So that critical point here, you have a relative minimum. Sometimes you don't have to say the word. Unmute balik. Okay. Macam mana boleh hilang? Okay, saya check recording. Recording saya. Oh, recording on. Alright. So that is essentially the first derivative test, where you can determine, all right, whether the function has the relative maximum or minimum. Based on what? Based on by just using the derivative. All right. So I will summarize the test. What are the steps that are involved in getting that critical point and conclude whether that critical point is a maximum or minimum. Alamak, ini tak lepas. Okay, so this is the rule. I will summarize the things, and then we will look at a few examples. Okay, number one. This is called the first derivative test. First derivative test means derivative test. Okay. First derivative test. Oh, dengar tak saya punya? Can you hear me? Or it's not clear? Okay.
Sir, sorry, sir, stuttering, sir. It's cutting off. We can hear you well.
Oh, play juga.
Yeah,
Okay, now okay. Sekarang okay sikit. Because connection
better. I think your connection, yeah.
Yeah, connection. Selalu petang kan ada ni lah, ada masalah. Mungkin I don't know, internet saya kot. Now better sikit. Connection is not good. Connection dah good lah. Okay sikit.
Okay, second.
So kalau dia dah tu lagi cakap lah, janganlah takkan chat. Susah lah beritahu lah saya. Takkan chat, susah. Saya kena check pula chat tu. Okay. Given a function. Apa dia?
Dia still macam ada lagging saya. Sorry saya. Dia tak clear. Dia macam ada cut.
Yeah. Okay, tak apa. I already do the checking. So saya tak tahulah apa masalah dia. Nanti saya kena beli ini baru punya earphone ni. Earphone ni saya baru beli ni. Kena beli yellow sikit ke? Tak tahu lah. Masih potong-potong masih dia.
Sometimes dia okay sir. Sometimes and then dia start potong-potong balik.
Okay. Okay, so just bear with me. If it's not clear, I will repeat myself. So given the function y equal to f of x, what we do firstly is that first find the critical point. Okay. Critical point or points can be more than one. This is where what? This is where y prime equal to 0. So you set y prime equal to 0. Suppose that will happen at x star y star. Okay, so that is critical point. That is first thing that you need to do, because like I said, the critical point will take into interval the curve or the value of the function. Secondly, based on the x star, okay, based on x star, then we break into interval. Break y into interval. Break y. Break y lah. So this is what we do. Based on the thing, you just draw a number line. Okay. Now that suppose the 0 is over here, but this thing here has nothing to do with 0. All right. It's just to do only with x star. Suppose our x star is there. So what do you have here? How many intervals do I have? I have 2 intervals, one over here, one over there. So I have 2 intervals, negative infinity to x star, and then x star to infinity. Okay, and suppose if I have this is 0, the x star is somewhere here. Again here, you have what? You have 2 intervals, one over there, negative infinity to x star. The other is to the right, x star infinity. So that x star will break the function into intervals. Okay, right? So after we do that, all right, after we do that, number 3, you take a test point for each interval. Okay, for each interval, you take a test point. Just like what we were doing for the inequality. Take a test point. And then you will see how the y prime, and then you can conclude the y. Okay, the detail here we'll do by an example. So you take a test point, you check whether the y prime, all right, whether the y prime is negative or positive, or where or from which you can conclude, or you can see the behavior of the function. Okay, so that's basically the test. And number 4, we can conclude. Okay, we can conclude whether you have a maximum or minimum at that critical point. So that's how the test is. How do you conclude? You can conclude from the table. Okay, you conclude from the table. Or you can conclude by sketching the graph. Okay, sketching the graph. So the table, I will show you afterwards. Sketching the curve, we already know how to do it. Okay, all right. So let's consider an example. Kita ada buat example. Tak ada lagi kan? So let's consider an example. Okay. Suppose example 1 here. Suppose I have a function here, y equal to 4x squared. Now you want to sketch the graph. Okay, sketch the curve, how the curve look like. And then I want to determine whether the function has a maximum or minimum at the critical point. All right, so that's basically what you do. So we apply the first derivative test. Number 1, you have to get the critical point where y prime equal to 0. So therefore, we just find y prime. Okay, now what is y prime? Y prime is dy dx. That is equal to 8x. Okay, now critical point, y prime is 0. So, okay, what do I have? I have 8x equal to 0, x equal to 0 over 8, that is 0. So you can call that is that x star. Correct? Now, based on the x star, I want to find y star. Okay, now how do you find y star? Where do you substitute the value x star equal to 0 into what? Into which function? To find y star, I put back into the original function. Okay, so I substitute x star equal to 0 into where? Into y. All right. So y equal to 4, 0 squared equal to 0. So we call it y star. So I got the critical point, okay, x star y star equal to what? Equal to 0, 0. So you know the critical point is 0, 0. That is where the slope equal to 0. Now, when the slope equal to 0, as we mentioned earlier, we can break into interval. Interval on the left of 0, 0, interval on the right of 0, 0. So very convenient because it is at 0. So you just, sketch the number line, and incidentally, it happened at 0, which is our x star. Then what happened here? I have two intervals, one to the right, one to the left. To the left is negative infinity to 0. To the right, 0 to infinity. So here, I want to determine what is f prime. Okay, and then what is y? Oh, same thing over here. We want to see how is the y prime behaving, and then you can conclude the behavior of y. To make it more systematic, you make a table. Okay, so we have the table already. Okay, we know how to do the table. So you set y prime and y. So first interval, negative infinity to 0. Second interval, 0 to infinity. Now we need only test point, one test point per interval. Okay, because over the interval, if the y is increasing or if the y prime is positive, it will be positive everywhere in that interval. All right. So well, you can take 1 point. I can take -1, or you can take -5 or whatever. Okay. So let's say I take x equal to -1. -1. Then we want to check y prime. So what is y prime? Y prime is 8x. Remember 8x. So 8 times -1 equal to -8. Now -8 is less than 0, negative. Okay. Now if y prime is negative, what about the function? Is it increasing or decreasing? Decreasing. Okay, so here y prime positive, we can say that the function is decreasing. Okay, now for the other interval, take one test point. What test point do you want? Simplest is 1. Okay, so what is y prime? Y prime is 8 times 1 equal to 8, and that is positive. So y prime is positive. I don't have to write down again y prime bigger than 0 because I already say here. Then what about y? Y increasing. So you can see there, okay, you can imagine the curve. 0, 0, the slope is 0. On the left, the function is decreasing. In other words, the slope is negative. And then to the right, it is increasing. Okay, so you can sketch the curve. All right, so from here, intuitively, you can imagine how the curve look like. So if I can do that, we have the curve. Now we just need to sketch. Okay, you don't need to draw. So what is important is the critical point. So critical point is here, 0, 0. Okay, and I know interval to the left from negative infinity, the curve, the function is decreasing. And after that, it's increasing. So therefore, you can do like that. Decreasing, I mean, like that, like that. You can draw it on the left, but it's difficult to get into that. So that is y equal to 4x squared. Okay, and what can you say about that point? Y equal to 4x squared has what? Has a relative. You don't have to put the relative, it's okay. Minimum. At what? At 0, 0. Okay, you just sketch the graph. And for the argument's sake, why it is a minimum? Because you can say on interval to the left, okay, interval to the left, y prime is negative. That means the function is decreasing. And then, okay, after that, y prime positive, the function is increasing. So therefore, you have a minimum. The function is decreasing and increasing. It's just like they go down the valley. Okay, if you go down the valley, that means you have to walk down and then you have to climb back. So that critical point, the flat area between the hills is the valley. Okay, and then go up. So that is the minimum point. So for test, first derivative test, the best way to do it or to make the conclusion is by drawing the graph. No, yeah, sketching the graph based on the behavior of the function. Okay, I think that's it for today. We will continue with the quiz. Okay, before we start the quiz, I would like to give you a few announcements. Announcement. What? Okay, we have now is 4 o'clock. So you have about 40 minutes, 45 minutes. Now we stop at 5. Now it's 4 o'clock. 4:45. So you start now. We will stop at 4:45. Then you submit. All right, submit to classroom. I will create the quiz. Okay, I will create the quiz where you will submit. Now, if you have no time to scan, if there is a problem scanning, so what you do, you just take the pictures, okay? Take pictures nicely, send it, okay? Send on time, because what I want is on time. I want everybody to send on time. So you send the pictures taken by your handphone to me, to the classroom. If it is not very good, later on, you can do the scan and submit again, okay? And resubmit. So these pictures is just to record, you know, so that I have a record that you submitted, and then you resubmit the same thing, okay? After that, okay, is that clear? All right. The most important, you submit on time. If you cannot do the scanning because of no time or whatever internet problem, take the picture, send to me. If you cannot send to classroom, WhatsApp je dulu. Okay? All right. So I think that is the most important announcement that I have to make. Okay, so now I show you the question. Okay, this is the question. Okay, one more thing. I want you to turn on your video. Okay, for the test, like I said earlier, turn on the video. Okay, please turn on your video. Then at least we can improve the invigilation. So this is the quiz. You write on a piece of paper. Don't write here lah. All right. So you put your name, your matric number, and then section number. And I want you to write in ink. Use pen, okay? Use ballpoint pen. Do not use pencil. So don't use pencil. No pencil, because it's not clear. If you do pencil, when you scan or you submit online, you know, it's not clear. So do in ink, all right? And then show all work. You don't need rough paper, okay? You don't need rough paper. Okay, don't need rough paper. Show everything on your answer book, okay? Show everything. It's okay. Show me more steps than less steps. Show everything on your answer book, because it's better for me to see what you're doing. Okay? Don't just give me your answer. If you just give me your answer with the step, then I suspect you cheating or copy. Okay? So you don't need a rough paper. Just do everything on the answer sheet. So you don't have to cancel or whatever. Okay? You don't have to erase anything. Just continue. Okay, if you make a mistake, just close it. Right? Okay. So first of all, I would like you to read the oath of honor and integrity. This is the university rule, all right, for us to be accountable for what we are doing, so that the work will be our own. Okay, the test is based on, it's just to show our ability and understanding. So please read the oath and make sure we obey by it. So you can start now. Okay, there are only 2 questions, and you can stop at 4:45. Or if you finish early, you submit early. Okay, all right. So I wish you luck, good luck, and do it now. Okay. Right. So turn on your video. Okay, I want to see. The. Okay, good. Okay, Shabila, you turn on your video, please.
I already turned.
Okay. Nih, Mukmin, video, mana video? I want to see you. Now, if you don't turn on your video, I will deduct mark. Okay, because that is against the rule. Or even I will not grade your work. Yeah, okay. This is, thank you. This is 68.5. Yeah, thank you, because I put a comma. That should be 68.5. All right. Somebody has answered for me already. So, saya terletak comma. Okay, we have 5 more minutes.
Sir,
Yeah.
sir,
Yes.
in 4:45, you want us to submit it or to just finish?
4:45, you finish and submit.
Ah,
Okay. So 4:45, finish and then submit. But if you finish early, okay, if you finish earlier, you can submit when you finish. All right. Earlier is okay. Actually, earlier is good.
So just to be sure,
Yes.
you want us to send the picture on Google Classroom, correct? First?
Yes. Even
Okay,
if you You take pictures, you send to classroom. Okay. After that,
Okay.
after that, if the pictures are not so good, after that you scan. Okay. Then you resend also to the classroom.
Okay, got it, sir.
All right. But you don't delete the first one. Okay. You just send the second one. Okay.
All right, noted.
All right.
Do we need to send by PDF or not?
Oh,
Or
yeah,
just
yeah.
send? No need.
PDF lah.
Oh, PDF. Okay.
PDF better lah. But
Okay.
since there are only 2 pages, picture is okay because there are only 2 pages. But if you PDF, better. PDF senang sikit.
Sir, the PDF tu you nak satu PDF satu soalan ke?
Tak.
Boleh duduk sekali kan?
Yes. Everything in one PDF.
Wait, sir. When we take a picture of our paper, we don't need to. We just need to put in our answers, right? Do we need to also write the question along with it?
No. The question
Okay.
I already have.
Okay. So just
Okay.
put the question number and the answer. Got it.
Yes.
Sir, do you want the PDF to have a specific title?
No. Just put the title on the top of your answer. First page, top, you say quiz. That's it. Okay, but you don't have to have a cover page, tak payah lah. Okay, because that will go into the quiz part, quiz section in the classroom. So everything will be together. Okay. Just write down the quiz on top of the first page with your name and matric number. Okay, when you have submitted, you can leave. Okay, you can leave the Zoom class. You can leave the Zoom meeting.
Okay, sir, thank you.
Okay, thank you.
Sir, my submission might be a bit late because wasn't my Microsoft is having a bit of issues right now.
Then you send through WhatsApp. Okay.
Oh, WhatsApp. Okay then.
Just WhatsApp to my number, and then you resend to classroom. Okay. All right.
Wait, I sent to WhatsApp and then.
And then you send to classroom.
Okay, noted.
Same thing. Okay. Same thing. Make sure same thing so that I have a record of your submission.
Sir,
Yes.
I didn't do it PDF. Can I send a picture to you in the WhatsApp? Then I will do it.
Yes. You send the picture first, and then you redo the PDF.
Okay.
All right. Because what is important is the record of your submission. And make sure same thing, okay? Don't do any adjustment after that, okay?
No, same picture.
All right.
Thank you, sir.
Okay, thank you. Apa dia?
All right, thank you, sir.
Okay, thanks.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Okay, thank you, sir.
Okay, thank you.
Thank you, sir.
Yeah.
Okay, I think everybody should stop now. Okay, just send whatever you have. Okay, now it's already 4:50. Okay. Okay, cepat. That's it. Okay, stop now. If you're late, then I will record yours as late. Cukup tu.
Sir,
Yes.
I have sent through WhatsApp. Do I have to mark as done at Google Classroom?
Yeah, you can put at the comment.
I
Okay.
already put in the comment. I state there that I have sent WhatsApp.
Okay. That will be good.
Okay.
Okay, I'm going to end your class. All right. If you send late, I'm not going to accept because the deadline is already being set. Okay, finish up. Hurry up.
Thank you, sir.
Thank you, sir.
Hello. Dah cukup. Cepat. Dah hantar belum? Hah? Sampai ni.